Hello, in this chapter we want to do the curve sketching, and we have learned several lessons before this lesson to prepare us to do the curve sketching. We have learned how to find the increasing, decreasing intervals by finding the first derivative, positive or negative. And also we have learned how to find the critical points where the first derivative equals 0 or undefined. And also we have learned how to find the point of inflection where the double prime equals 0, and the point of inflection, the double prime equals 0, is a point of inflection only if the double prime changes the sign. Change the sign, it means double prime positive concave up, double prime negative concave down. Only when the concave up, concave down changing, we call that point is a point of inflection. Otherwise, that point is not a point of inflection. It may be the maximum or minimum, local maximum, local minimum point. So now we are going to combine all our prior knowledge to see what we are going to use to help us to do the curve sketching. So the step 1, determine the x-intercept, y-intercept. That is what we have learned in grade 11, 12. To find the zeros and the y-intercept, and determine all asymptotes. We could use a limit to find the horizontal or oblique asymptotes, and using the zeros for denominators to find the vertical asymptotes. And if they are common factors from the numerator and the denominator, we call that common factor, which we can solve for the zeros. That point is a whole, not a vertical asymptote. And also we want to find the critical points, f prime equals 0 or undefined, from where we have the maybe local maximum or maybe local minimum. And also we want to find the points of inflection, the double prime equals 0 or undefined, and at that point, only if the left side and right side, the f double prime, change the sign, we call it point of inflection. Otherwise, we call that is just the local maximum or minimum. If f double prime doesn't change the sign, it doesn't change the from positive to negative, negative to positive. And we could just so for this one, f prime x equals 0 is kind of, you have these points, and sometimes you may have this point is f prime x equals 0, but from there you will see that for this one is concave down, so f double prime is positive, and this one is concave up, the f double prime is less than 0. And here the concave down, then concave up, so double prime is positive, double prime on the left is negative, because this is a point of inflection. And all the f prime equals 0 is critical points. So they are definitions for critical points, and the point of inflection must have the sign change. Otherwise, we don't call it point of inflection. If sign doesn't change, for example this one, it will be the positive, both positive. Okay. And after that, we calculate the critical points, the y value, c, the f at c, to find those points to help us to do the graph. So now we are going to see an example. So it asks you to sketch the graph of this one. And the first step, what we want to find is y-intercept. That will be the easiest one to find. Y-intercept, it means on the graph, on the y-axis, so the x value is always 0 on the y-axis, so we sub in x equals 0. So if it's in standard form, the last number is our y-intercept. The reason is we sub in x equals 0, all those terms with 0, they are zeros. So after that, we are going to find the x-intercept. For this one, in order to find the x-intercept, we need the advanced functions knowledge. So we have to find what are the possible factors for this function. So possible factors for this one, we could check. So you will see all the number coefficient at front. 1, -3 plus 11 minus 6. All the positive number 1 plus 11 coefficient is 12. All the negative number -3, -3, -6 is -12. It means when x equals 1, we sub in, it will be just a coefficient left. Altogether will be 0. So from the factor theorem, we know if f at x equals 0, it means this is a 0, so x minus 1 will be a factor. So this equation will have the x minus 1 as a factor. Then after that, you could use a long division or synthetic division to find the coefficient, whatever another factor, and I will show you another method that is just comparing the coefficient. So what it means, whatever left in this bracket is first term divided by first term. So x to the exponent 4 divided by x, we have x cubed. Then you will see first term times first term is x to the exponent 4. It works. Then the last term. So last term, which number times give you -6? -6 divided by -1. So last divided by last give you +6. This is our last number. Then we have two numbers at middle we have to find. One is x squared term. How to find the x squared term? We want to find using the cross times. So these two times give us minus x cubed. And these two times give us quotient x cubed. These together should give us the -3x cubed term, because all the other, this is x term, all the other terms times won't give us x cubed, only these two. So minus x cubed plus what give us -3, it will be -2. It means here is -2. So we have the second term. Then we continue to find the x, what are the at front of x. Then we use the cross times again, and this time we use x squared. So these two times give you x squared. These two times give you x squared, no other terms. So -1 times -2 give us +2x squared. Then plus question mark, x times x give us x squared. Look at the original equation, we have -3x squared. So 2 plus what give us -3 is -5. Then we know that here the question mark is -5. -5x. So this one, we have this factor done. Factor form done. And if you not sure, you can just check x cubed, x to the exponent 4, -2x squared, plus 2x squared, -5x squared, cubed, sorry, -1, -2 give us -3. Then +2 -5 give us -x squared, 3x squared. For the x term, it will be these two. So -1 -5 is +5 plus 6 is +11x. And for the constant, just last term, -1 times +6, -6. So it works. And after that, we have the second bracket is an expression of the cubed. So we want to find the factor again. So we try the positive number at the coefficient only 1 minus 2 minus 5 plus 6, we have 0 again. So x equals 1 sub in will give you 0. So you have another x minus 1 as factor of this one. So we do the same thing. We do the division. X cubed divided by x is x squared. Last one, 6 divided by negative 1 give you negative 6. And this time we only have x we have to find. So minus x squared plus quotient x squared give us negative 2x squared. So it will be minus 1 x squared give us negative 2x squared. Then we can use the x term to double check. So for the x term, these 2 times give us x term. These 2 times give us x term. So minus 1 minus x is positive 1x. Then minus 6x, 1 minus 6 minus 5x. So it works. So I will rewrite it properly. So it's minus 5x. And here is minus x. Then continue. The second bracket, third bracket, we want to factor it again. We copy the first two, x minus 1, x minus 1. This is a simple trinomial. We have to find two numbers times together, negative 6, add together, negative 1. So find the factor of 6. It's 1 times 6. The next one, just use 1, 2, 3, 4 to divide. 6 divided by 1, 6. 6 divided by 2 is 3. 6 divided by 3, so just use 1, 2, 3, 4, keep going. So 6 divided by 3 give you 2. Then repeat, we ignore it. Then add together is negative 1, so larger number must be negative. Then the two number add together will give you negative. Times together is negative, one number negative, another number need to be positive. Then these two numbers we have to get minus x. So 2 minus 3 give us negative 1. 1 minus 6 give us negative 5. So this one doesn't work, and this one works. So add together give us negative 1. So plus 2 minus 3. So this is simple trinomial. And here, if you are having difficulties in finding this factor form, please go back and practice on the optional practice from advanced functions. Just focus on factoring part, okay? So this one, x-intercept means y equals 0, so let the whole thing equal 0, and each factor could be 0. So from this one, x minus 1 equals 0, we have x equals 1. And this one give us 1 again, so this is kind of like a double zeros. And this one is negative 2, it's opposite, x plus 2 equals 0, move the plus 2 to other side, opposite. X minus 3 equals 0, move the minus 3 to other side is positive 3. So we have the zeros is negative 2, 1, and 3. We have these 3 zeros. Then next step, we need to find all asymptotes. So from this one, this is a polynomial functions. So for the asymptotes, we know the definition for asymptotes. Horizontal asymptotes is the definition is a numerator and the denominator's degrees. So if it's n less than m, we have y equals 0. And here we are going to see we have n equals 4. The denominator is no x, m equals 0. So it's no, not less than 4 is not less than 0, so no horizontal asymptotes. And for the oblique asymptotes, only when n equals m, then it will be the number at front give you the oblique asymptote. But this do the long division, then you will have the n equals m. Horizontal asymptotes is n equals m, the number at front, but this one is less than, is greater than, so this is so no horizontal asymptote. Oblique asymptotes is n is greater than m and equals n plus 1. And here is not that case. If n equals n plus 1, we do the long division. Then the vertical asymptotes. Vertical asymptotes is denominator equals 0. For this, we could think the denominator is 1. So 1 is not 0, so no zeros from the denominator. It means no vertical asymptotes. So there's no asymptotes. Then the next one. So the next one is looking for the critical points. We need to do the derivative to this f at x. So we are going to do the derivative. So it will be the f prime equals 0 or f prime is undefined. So this is polynomial. We are going to have the f prime x equals f prime x equals degree to the front, then degree minus 1. So 4x cubed minus degree to the front, then degree minus 1, degree to the front, then degree minus 1, degree 1 to the front, then 1 minus 1 is 0. So x to the exponent 0 is 1 is gone. So this is f prime x equals 0. So we are going to continue. We have 4x squared cubed minus 9x squared minus 6x plus 11. Then we are lucky, you will see 4 plus 11 is 15, minus 9 minus 6 is minus 15. So minus 15 plus 50 is 0. It means x equals 1 is zeros for that one. So f prime 1 equals 0. It means x minus 1 is a factor. Then we do the first term divided by first term again. Last term divided by last term. So it will be minus 11. Then the middle is just find the what add together give you negative 9x squared. Minus 4x squared plus minus 5x will give you minus 9x squared. Then double check the negative 6x term. So for the x term, you will see it will be the minus 1 times negative 5. Give you positive 5. Then minus 11x give you minus 6x. So it works. Then f prime equals 0. We let it equal 0. Each denominator equals 0. Each factor equals 0. So x minus 1 equals 0 is x equals 1. And for the second one, we are going to see if it's not factorable, we need to use quadratic formula. So this one, 4x squared minus 5x minus 11 equals 0. And 4, 11 is times together. This is a complex trinomial, so you need to find two numbers times together, negative 44, add together negative 5. The factor of 44, we try divide by 1 is 44, divide by 2, 22, divide by 3 doesn't work, divide by 4 is 11, divide by 5, no, 6, 7, 8, no. Then until 11 it will work, but repeat, we don't need it. Then the two numbers add together is negative, the larger number must be negative. Times together is positive, so one negative, another number need to be positive. Then times together, you will get negative 44. Then check which one add together is negative 5. None of them. It means it's not factorable. And even if a function is not factorable, we are able to find the zeros by doing the quadratic formula. So a equals 4. B equals negative 5, C equals negative 11. Then it's negative b plus minus square root b squared minus 4ac all over 2a. then sub in the value, so negative, then b is -5 plus minus -5 squared minus 4 times a is 4, c is -11, then all over 2 times a. So get your calculator out, then find the x value for the zeros. Then you will have one is x approximately. If it's a plus, we have 2.397, and if it's a minus sign, we have approximately -1.147. So the critical points we have 3 critical points, -1.147, 1 and 2.397. So 3 critical points x value. And question 4. So critical points, it doesn't matter is changing the sign or not, as long as f prime equals 0 or undefined, they are the critical points. Then the step 4, we have to find the point of inflection, f double prime equals 0 or undefined, but here the sign must change. So we are going to copy this one to the other side. So f prime, then we do the derivative of this one again to the next page. So step 4, we find the double prime equals 0 or undefined. F prime x, we copy it here, is 4x cubed minus 9x squared minus 6x plus 11. Then double prime is derivative of this one again, degree to the front, degree minus 1. So I will just 4 times 3 is 12, x squared, 9 times 2 is 18, then x, this one minus 6. Then we factor this one in order to find the zeros again. So common factor 6, 2x squared minus 3x minus 1. Then we are going to find the double prime equals 0. So set this one equals 0. And divide is 6 to both sides. We only have 2x squared minus 3x minus 1 equals 0. And a is 2, b equals -3, c equals -1. Use a quadratic formula again. We have x equals negative b plus minus b squared minus 4ac all over 2 times a. Then get your calculator out. You will have x plus approximately 1.781, x minus approximately -0.281. So these are the two possible point of inflection. We have to draw the chart in order to find it is open up or down. Okay, so this is this part. Then we are going to draw the chart. To find the concave up or concave down. So file is draw the chart for f double x. Then we have two. It will divide the x-axis to 3 intervals. So negative at left side, smaller on the left side, larger number on the right side. Okay, so we pick any numbers of this part, or we could think this is just a quadratic, so it's open up. Then we have two zeros, -0.281, 1.781. So if we pick a number on the left side, we know it is positive. And between these two will be negative. And on the right will give you positive again. So it means here is concave up, here is concave down, here is concave up, and at these 2 points the concave is changing, so it means it is a point of inflections. X equals negative 0.281, x equals 1.781. So these are the 2 point of inflections. So next step, we just need to find all the when x equals those value, what the y value is. So question 6, we are going to find at critical points, x equals 1, y equals what? Negative. So critical points, they are the negative 1.17 and 2.397, and also the point of inflection is x equals negative 0.281 and 1.781. So subbing to the original function f of the x, what we are going to have is subbing 1 is 0, negative 1.147 give us negative 16.3, and 2.397 subbing give us negative 5.17, and when x equals negative 0.281, we have to do the calculation. So we have the negative subbing negative 9.25 for the f at x, and 1.781 give us negative 2.81. So we have those 5 points we could put on the graph more accurately. So now we are going to draw the graph. Okay, so we set up the x and the y first. The reason why we pick the x here, because the y value, the minimum is negative 16.3, and for the y value, the maximum, we come back to see is negative, y intercept is negative 6, so the x intercept is negative 213, no asymptotes, and these are the values for the critical points. Those points are here already, so each of them, maximum, minimum, you will see that for the x, the maximum is 3, minimum is negative 2, so then we don't have to give the x scales bigger, so it's just 1, 2, 3 good enough. We can cover all the x value from our critical points. And for the y value, the minimum is negative 16, 1, 2, 3, 4, 5, 6, 7. So we may just go by 3. So negative 3, negative 6, negative 9, negative 12, negative 15, negative 18. Then 3, 6, 9. So the zeros is the zeros from the last page is negative 2, 1, 3. So negative 2, 1, 3, they are the zeros. Negative 2, 1. So negative 2, positive 1, and 3, they are the zeros, and 0, negative 6, this is your y-intercept. After that, this is critical points. These critical points could be the maximum or minimum. It depends on that point. It is concave up or concave down. So negative 1.17, this one is concave up, so it's minimum. This is minimum, and 2.39 is here is maximum. local maximum. So these are the, and 1, 0 is here, so it's max, local max. Okay. So this one, negative 1.17, negative 16, this is our minimum. And 1, 0 is our minimum, is our maximum. So it's this direction. And 2.39, negative 5 is here. This is our local maximum. So sorry, it's 2.3 is local minimum. So this is a local minimum. It should go this direction after that. So this is our maximum minimum. How to determine that one? This is a double prime. This is a double prime is a negative, so it's open concave down. This part is f double prime is positive, so it's concave up, it's minimum. This one 2.3 is double prime is positive, it's concave up, so it's minimum. This is a minimum. So this is a okay. It's this direction, and after that we have this point of inflection. So negative 0.28, negative 9. So this point on the left is open up. So open up is minimum, it's here. So this is a open up. So this is concave up. So it's concave up. This is concave up. And on the right side is concave down from here to 1.7, 1.78, 0 point. This point to here is open down. So this is down. So this is up, this side is open down. And after that, after 1.78 is open up again. So from here is open up again. So this is a graph. So what we have found is we find the zeros. They are the negative 2, 0, 1, 0, 3, 0. Then after that, we find the y-intercept. After those, we have found the minimum maximum. So maximum local is 1, 0, and the minimum local is negative 1.1, negative 16. We could just round it because it's hard to read after the decimals. So 2.4, negative 5.2, they are the minimum. Then we find the point of intersection, inflection. So these are the points that we have used. 1.8, negative 2.8. So these are the points we have used. So this is a point of inflection, and here this one is point of inflection. So maximum, minimum, maximum, and also 0, 0, 0. So altogether 1, 2, 3, 4, 5, 6, 7, 8, 9. So altogether 9 points. So this is a long question, sorry. And this is how to graph a curve more precisely. So what you have to give is zeros, x-intercept, y-intercept, and the maximum minimum points, point of inflections, and based on those we can graph it. We don't have to find the negative, positive intervals for like we have done in advanced functions. The reason is we know from minimum maximum how it will go up or down. Then we know the trend of the graph, we can graph it. Okay, so this is for today's lesson. So what we have done is we follow the steps: xy intercept, find the asymptotes, find the critical points. Critical points doesn't matter the f prime x change sign or not, as long as equal 0 or undefined, we call it the critical points. And the point of inflection only happens when the f double prime changes the sign. Otherwise, we don't call it point of inflection. If f double prime doesn't change the sign, it is a local maximum or minimum. Change the sign, concave down, concave up. This is point of inflection. Then after that, we calculate the values for critical points and also point of inflections. Then combine with xy intercepts, we can graph. So the assigned work is on Delta Math 4.5 and 4.6 together. So there are unlimited questions. For most of the questions, you can click on keep practicing, then it will give you more questions to solve. And use the decimals.com to check your answers. So the website, very good website, is decimals.com to check your answers for graphing. Okay, thanks for watching.